of that we use a lot of resources, and not just understanding how much fuel is being burned and what is that pollution, but also to understand where is that pollution and when is that pollution. I'll give you an idea and selective overview of some of the total resources that we are using to create this program. One of the main questions, I'll drive all the examples from the city of Mumbai. One of the main questions, whichever city you go to, the question that will be asked is where is the pollution coming from? And to answer that, we need a lot of information. And this is where some of the work that people do in work is doing. So you can answer that question by measuring where the pollution, but you don't have enough measuring instruments across the city to answer that question. So in absence of monitoring, you have to do a lot of modeling work to understand where the pollution coming from. If you look at where are spatially or temporally these hotspots are within the city, say a plot for Mumbai will look like this. But to get to this point, a lot of resources are needed to be put together. And one of the resources to answer the where question, we use a lot of different resources. So one of the products that we use is actually the data area. And we look at time series of how the cities have expanded over the years. We can use some information like this to understand where are the urban hotspots. So this has direct impact on construction sector, energy demand, transport demand, and in general commercial activities demand. And for these commercial layers, information is also available as one of the Google APIs. So we use that layer as well. There are the hospitals, hotels, cinema halls, restaurants. So all these layers of information can be really useful in understanding where are these emission hotspots. One example for where One example of where this can be used is the diesel generator sets. Okay, we do have a lot of power cuts. So if you look at hospitals cannot afford to have a power cut. Right? So they always have 24/7 they are running diesel generator sets. So if we have an idea of where all these activities are happening within the city airshed, we can then use the information from the power cuts to associate that with how much diesel is being burned at each of those hotspots. And that's one of the layers that goes into understanding where these emissions, where are the emissions. Another layer that we use in understanding the hotspots of emissions are the directions API in Google Maps. So this tells us if we create a origin and destination matrix, if you are going from point A to point B, and it tells you it's 10 kilometers, it takes you 10 minutes, you can convert that information into speeds and provide the city and also for our calculations, there are the hotspots, the conditions on this. In chemistry terms, this information can be translated into how much emissions of CO or VOCs are coming from condition activities. So if vehicles are idling in a certain section of the road, it is incomplete combustion. So it actually changes your chemical profile of that area. So within the main urban parts of the city, you have a different emission profile compared to the rural areas of the same area. So we can build this function both there and using some of these data extracts from that. So we do this more technically. For example, in the urban areas, we make a lot more of these, larger number of these urban destination calls. And then as we go on to the rural side, we reduce the calls, but we increase the size of the calls. We have to do some kind of optimization so that we can do these calls and analyze them in real time so that we can have a forecast for the next few hours and also for the next few days. And for different cities, we do it at different levels. In case of Delhi, we do it at a much larger scale. We make 300,000 calls for the city of Delhi to differentiate both your urban transport and your fleet transport over the highways. So all this is through the APIs from Google Directions API. We can also use this. You make enough calls on these, you have enough database, you can then start differentiating between weekday versus weekend. Not just the peak hours, but weekdays how is the profile and weekends how is the profile. So you can use that for generating emission profiles for your economy. We have done this for now 30 odd different cities across India and a few other places outside India as well. And it gives a very rich understanding of spatially where are the hotspots in the city, and it has direct implications for urban planning. So it's just some of the layers. So there's also imagery that can be useful in understanding where the hotspots are. So some of the examples like this. Every one of these images I'm showing you is 1 square kilometer. This is a hub which is very close to the Victoria docks, and in this square kilometer area you have at least 5,000 trucks moving in and out every day. And these are dusty parts. What it means is not just the vehicle exhaust emissions we have in this part, but we also have a lot of dust resistance constantly happening in these areas. And you have plenty of these hotspots are spread across the city. So once you do it physically with eyes, of course, scan across the city, you start looking, you can find out all these hotspots and can be used for allocating emissions. They are not just based on commercial activities, but also on some of the physical activities. And imagery can also be used to understand the size of different activities. So this is the Victoria docks. You can see that it's almost close to 6 square kilometers of activity. So there you have freight handling, the freight is coming in and going out. So which means there's a lot of idling that's going to take place in this area. And ships are coming and hanging out here, so you can also understand where the docks are and how that can be used. Similarly, there are some unidentified sources that are spread across the ocean. So these are actually brick kilns which are manufactured, but these are not brick kilns, official brick kilns with chimneys. These are just piled, sun-dried bricks that are piled up and then burned. And these areas are also spread across the city, so you can physically understand how big are these areas and use that for emission calculations as well. This is a big refinery which is in the south of Mumbai area. This is another textile units. In this 1 square kilometer area, there are at least 300 textile units harbored, and they use a lot of solvents for dyeing activities. So you can use that for understanding how the emission loads are. Similarly for other sectors as well. And when you're scanning, you also find places where you don't know what they are. Now, this is a big industry. There's a lot of coal being handled in that activity, but we have no idea if there are no records of what this industry is. So then we basically send these images on to local groups and ask them to find out what is this industry, what are they doing. Then we can use that for cross-checking as well. So there are some wire mills. And one of the main thing is garbage. Now, a lot of garbage, there are some landfills that we know where they exist, but there are also unofficial landfills spread across the city. So in order to find that, we use the imagery to map out where they are and how big they are. And these areas have a direct implication for methane emissions. If they are burning on a regular basis, then we have a lot of CO and VOC emissions that we can map out.
I can also take pictures in the videos.
There are dumping grounds. So there was a large fire in March 2016. So this is also same satellite imagery. So we know exactly how big the landfill is, and if we have disasters like these, you can immediately start adding it to the emission inventory and find out where it is. And you also have a lot of these brick kilns. They are not in the city, but the demand for bricks is in the city. So we can't directly use the footprint of construction to assign a weightage of what is the emission coming from those bricks. So we need to map those. And if you get out of the cities a little bit, then you start seeing these quarries. So all these quarries are off-grid, and they use some of the oldest truck engines modified for crushing rock. So we can map out these areas only if we look at the imagery on a much finer scale. And this is the city of Pune. The area marked over there is about 11 square kilometers. It's pure rock quarrying activities. And some of the oldest trucks which can't run in the city will go there and operate there. So we can use these as to understand where the hotspots are. So once all these different types of layers of information comes together, along with fuel consumption and information, then we can start looking at spatially and temporally where these emissions are. Then we use that for some policy dialogue with the cities. So this is just an overview of all the different layers of information that we use for understanding emissions and pollution and how that feeds into our policy discussions. We have a lot more information in 220, so if you come by, we're here for 2 more days. If you come by, we can chat some more. Okay, thank you.